We are solving systems of equations by elimination today. So it's another form of algebraic solution for a system of equations. So again, what you're trying to do is find the values of x and y that satisfy both of the equations. So when we have both of them together here, in this system, the y values are going to be the same and the x values are going to be the same, right, to satisfy this system of equations. So it's really, for this method, exactly what the word means. We want to eliminate one of the variables. We're going to do that by adding or subtracting the equations together. Okay, we might have to multiply one of them by a number or both of them by a number in order to get the same coefficient for that variable, and then we'll eliminate them. So taking a look at this system, they're not in any particular form of a linear equation, but they are matched up. That means the y's are first, then the x's, then the equal sign, then the constant. So in this case, it's quite easy to eliminate the y's. Put a line underneath, and we're going to subtract the second equation. I like to put brackets around the whole equation so that you're remembering that you're subtracting every term. So 3y minus 3y is 0, so those go away. 2x minus negative x is like adding x, so that's 3x. And 18 minus 9 is 9. Then you solve for x. Now, then we go back and we actually use substitution. So although elimination, we do that differently from substitution, we then substitute into one of the equations. Now, you could also go and eliminate the x's to get the y's, but substitution is often a little bit faster for the last part. So that's going to be, I'm going to put it into, let's say, the first equation. So then we'll have 3y plus 2 times 3 equals 18. 3y plus 6 equals 18. 3y equals 12. Y equals 4. If you ever need to stop or pause the video, go for it. So ordered pair is 3, 4 in your solution, or you write them out together. X equals 3, y equals 4. Okay. Make it clear what your solutions are. You should verify, so it does say verify the solution. So first equation, 3y plus 2x equals 18. So we'll have 3 times 4 plus 2 times 3 equals 12 plus 6, which is 18. And then we'll have in the second equation 3 times 4 minus 3, which is 9. That works. Okay. Okay, so in this equation, the coefficients on x aren't the same. Coefficients of y aren't the same. So we have to do something to make them the same or opposite sign. So I will multiply this by 2 to make the coefficients on x the same, or you can multiply by 3 to make the coefficients on y the same. So this will be 4x plus 6y equals 0. Second equation stays the same. And we're going to subtract. So those go to 0. 6y minus 9y is negative 3y. 0 minus negative 1 is positive 1. So y is negative 1/3. So you can have fractions, right? It doesn't mean that you can't. Then I'm going to substitute that back into one of the equations. Doesn't matter which one. I'll put it into the first one. But I'm going to put it into the original first one. Okay. And so now your solutions, 1/2 negative 1/3. So that's as an ordered pair, or you can go summarize it, x equals 1/2, y equals negative 1/3. Okay. Next one. So this one has fractions in it in the second part. They're in different forms. The really important part about elimination is the terms have to line up and the equal sign has to line up. So what I want to do here is, for elimination, I don't want to keep any fractions. So I'm going to multiply first of all. I'm going to multiply this by 2. Okay. All right. Notice the order here. So maybe I'll put the first equation in that order. So that would be negative 5y equals negative x minus 6. And now match up. So the y coefficients aren't the same, the x's aren't the same. But if I multiply this by 3, okay, so this goes to here, then I will have negative 15y equals negative 3x minus 18. Copy out the other. And now I'm going to add the equations, okay, because these are opposite in sign. So this would be negative 13y. This goes to 0. And then negative 18 plus negative 8 is negative 26. Divide by negative 13, I get 2. So then I'm going to go back and substitute into, I'm going to go back into the first one. So x minus 5y, just because it doesn't have any fractions, right? And it's easy to solve for x. So that's x minus 10 equals negative 6. So x equals positive 4. So again, that's 4, 2, or x equals 4, y equals 2. Okay, to verify, x minus 5, y negative 6. So we'll have 4 minus 5 times 2. 4 minus 10 equals negative 6. And then we'll have 3 halves times 4 minus 4. That's going to be 6 minus 4 equals 2. And y is 2. So that both of them work. Okay, again, these aren't in the same form. So you'll notice here that you could divide this equation by 2. All right, because there's a multiple of 2. So this one's really not in simplest form yet. This one's in slope y-intercept form, but we've got fractions. So I like to get rid of the fractions first. So that's going to be 2y equals x plus 4. Okay, and notice the orders aren't the same. So here, maybe you want to solve for y. Okay, or maybe you want this one. So maybe noticing here, this is 2y, could bring the x over. So here, or everything to this side, I'll bring the x over. Negative x plus 2y equals 4. Then it's in the same form, right? I'll write this just above it. Okay, so they're all lined up, but unfortunately not the same coefficients. So now, if I multiply this by 4, negative 4x plus 8y equals 16. This, copy it out. I could have divided everything by 2 here and then multiplied by 2, but then that's another step. This now, if I add these equations, the x's go away, the y's go away, I get 0 equals 26. Well, remember back from when we solved by substitution, if we got something like this, that's not possible, right? So that means there's no solutions to this. Okay, so you can show that like that if you want, or just state no solutions. So when you try to eliminate, if you end up eliminating the x and the y, and you're left with something that doesn't make sense, so in this case 0 equals 26, then there's no solutions. Basically means these are parallel and distinct lines. So the slope is a half. If I were to solve this for y, I'd get negative 8y equals negative 4x plus 10. Divide by negative 8, I get positive 1/2 x minus 5 over 4. So same slope, different y-intercepts. Okay. Next one is 3 equations. So just like we did with 3 equations when we were using substitution, we want to pair them up. And this actually is the same system. So we'll see if we get the same answer. So you want to pair up and eliminate. So I'm going to start with this one and this one, because looking at that, the c can be eliminated right away. And then I've got to incorporate equation 2. So maybe equation 2 and equation 3. 3 is easy to multiply through by a number, right? So I'm going to do 1 and 3 to start. And so I'm just going to copy them out. And looking at this, I'm going to just add them together to eliminate the c's. So that's going to be 6a plus 2b equals 18. Okay, so now I'm getting it in terms of a and b. That means that when I deal with equation 2, I've got to eliminate the c's. Okay, I've got to get it down to a's and b's. If I try to eliminate a or b, then I'm kind of going around in circles. So now for 2 and 3, I'm going to copy out 2 because it has all the coefficients, non-ones, and I'm going to take equation 3 and multiply it by 7. Okay, so that's going to be 7a plus 7b plus 7c equals 28. Now, when I add those together, these terms go away. So I get 9a plus 4b equals 30. Now, looking back over here, 2 was common to both. So I could divide both sides by 2. That would give me 3a plus b equals 9. That's going to make it a little bit easier. So I'm going to call this equation A and equation B. And so now I can multiply this by 3 and eliminate A, or multiply this by 4 and eliminate B. I think I'm going to multiply by 4. So that's going to be 12A plus 4B equals 36. So this is really A. And then 9A plus 4B equals 30. So now to eliminate the B's, I subtract. So that's going to be 3A equals 6. So A equals 2. I'm going to substitute that into A. Okay, so 3 times 2 plus B equals 9. 6 plus B equals 9, so B equals 3. And now we have to go back to one of our original equations to get C. So I'm going to substitute these into equation 3. It was kind of the simplest equation. So A is 2 plus B is 3 plus C equals 4. So that's 5 plus C equals 4. So C equals negative 1. So then I'm going to summarize A equals 2, B equals 3, C equals negative 1. Okay, it's not an X, Y, Z, so I'm not going to put it in an ordered pair, although you would put it in alphabetical order if you did. Okay, and then solve each system algebraically, verify. Note, substitution and elimination are both algebraic. So you have a choice here. Okay, so this is kind of combining the last lesson with this one. So what you want to look at, if you have a choice, which we usually ask one question algebraically, one by substitution, one by elimination, and then anything more than that is always your choice. So here, because it's already solved for y, so that's a big hint that I would use substitution. Okay, rather than having to rearrange it and use elimination. So I'm going to 1 and 2, I'm going to substitute 2 into 1. So I have x equals, x minus 3 times 2x plus 6. Wherever there was a y, I put this expression. That equals 7. Expand the brackets, so that's minus 6x minus 18. That's negative 5x equals 25. So x equals negative 5. Then I'm going to substitute that into equation 2 because it's already solved for y. Y equals 2 times negative 5 plus 6 equals negative 10 plus 6 equals negative 4. So you can show this, because it's x and y, as an ordered pair, or as x equals negative 5, y equals negative 4. To verify, into the first equation, we're going to have negative 5 minus 3 times negative 4. Negative 5 plus 12 equals 7. And into the second equation, your y value is negative 4. 2 times negative 5 plus 6 is negative 10 plus 6 is negative 4. It worked. Okay, next one. Notice how this is, these are both quadratic. Okay, so in order, if you're going to use elimination for 2 quadratics, then you must eliminate y. Okay, if you try to eliminate x squared, you might still have an x and a y. Okay, so if you use elimination, you must eliminate y, or just use substitution. Okay, but in this case, they're all lined up, and so I'm going to eliminate y here. All I have to do is subtract the equations. So y minus y is 0. 2x squared minus x squared is x squared. Negative 5x minus negative 2x, is negative 3x. Negative 7 minus 3 is negative 10. Okay, and then you need to solve that. So we need to factor. 2 numbers that multiply to negative 10 add to negative 3 would be negative 5 and positive 2. So you have 2 x solutions. Now you take x equals negative 2 and substitute into, doesn't really matter, I'll put it into the first equation. So that's going to be y equals 2 times negative 2 squared minus 5 times negative 2 minus 7. So that's 11. I'll summarize it in a sec. And then x equals 5. So here and here. Into, again, equation 1 will be y equals 2 times 5 squared minus 5 times 5 minus 7. It's going to be 18. Okay, so we're going to have 2 solutions. So we'll have negative 2, 11, 5, 18, or say x equals -2, y equals 11, x equals 5, y equals 18. Okay. And you can verify them. I'm not going to go through the step of verifying. Okay, next one, they're both linear. This, because there isn't a coefficient on x that's 1 or the same 1 that you can solve for, and they're not solved for a particular variable, I'm going to use elimination. And in this one, I'm going to eliminate the y because it's really easy here to multiply through by 2. So that's going to be 10x minus 4y equals -26. I'm just going to move this word here. And then I'm going to copy out the first one. And then I'm going to add those together because they're opposite in sign. So that's 17x, that goes away, equals 9 plus -26 is -17, and so x equals -1. Then substitute into, I'll put it into 1. So then 7 times -1 plus 4y equals 9. So 4y equals 16, y equals 4. Okay, so -1, 4, or you can summarize. You can even put it horizontally if you want. Okay, but just summarize it somewhere. Now, one last thing I wanted to show you, because that was the last question, is what if you had something like 2x plus 3y minus 4 equals 0, and then you had 5x minus 2y plus 3 equals 0. So say you had this equation where you can't multiply 2 by anything to get 5 or 3 by anything to get 2 and vice versa. Sometimes you're going to have to multiply both equations. So in this case, I would think about, it's kind of like, what's the lowest common denominator of 3 and 2? It's 6. So I'd want to multiply this equation by 2 and this equation by 3. So basically by the other coefficient. Don't worry about the signs because you can either add or subtract. So now I can add these and those go away. So I'd have 19x plus 1 equals 0. So 19x equals -1, x equals -1 over 19. I just made it off the top of my head, so it's not a great number, but that's what you would do. And then you put it back into your one of the originals to solve for y. Okay, but sometimes you might have to multiply both equations. Okay, so just be aware of that. All right, so we're done.